Disc level, a product of Turntech Manufacturing. Disc level adjustable chock assembly allows for up to 5 degrees of angular opposition between load-bearing faces with a nominal bolt of the same size. No more trial and error. Radial ticks prescribe height change. Multiple ticks are observable for multiple angles. Alignment ticks prescribe height adjustment in 1/1000th of an inch increments for eyeball adjustment. Acute face angle for drainage. Unique mating faces encourage contaminants to run away from the threaded union. Acute angle encourages drainage away from engaged threads instead of encouraging debris and glycol to run into the threads. Concave surface also encourages drainage. Contact stress. Contact stress is modeled with Hertzian stress. Hertzian stresses can exceed the yield strength of a component without catastrophic failure, but it leaves a footprint on the mating parts after relaxing the load. General rules about contact stress. The larger the contact radii, the smaller the contact stress. The smaller the difference between mating radii, the smaller the contact stress. Misalignment between mating faces changes the stress distribution. Contact stress can exceed the yield strength of the part as long as loads are applied statically, but it creates a residual footprint between mating parts. Non-uniform loading is no longer predictable under a Hertzian contact stress model. What is FEA modeling? It is a computerized numerical analysis technique used for solving differential equations to primarily solve mechanical engineering problems relating to stress analysis. It involves creating a mesh structure and analyzing stress at the nodes in the mesh. This mesh can be characterized by dividing a solid into a bunch of little volumes. The points where these little volumes join are called nodes. Stress is then analyzed at the nodes and can be used to model how a complex assembly reacts to reaction forces applied to it. It verifies calculations to predict failure. FEA modeling of adjustable chocks. On the left, an adjustable chock is subjected to a published distributed load. Stress is then analyzed using an FEA model. With an aligned chock, stress is evenly distributed. On the right, an identically sized disc level is subjected to an identical distributed load. With an aligned chock, it behaves equally well. Misalignment makes a difference. On the left, an adjustable chock is subjected to a published distributed load under a state of 4-degree misalignment. The stress is then analyzed using an FEA model. With a misaligned chock, stress is observed to be shared into the flank face and engaged threads, and stress risers are observed at the concave convex surfaces. On the right, a disc level is subjected to identical loads and conditions. With a misaligned chock, the stress in the threads has little change between aligned and misaligned conditions, and the stress is well distributed into the concave convex surfaces. Assumptions about these studies. Materials are identical grades of 316 stainless steel. Loads are identical assuming 48 kilonewtons. Misalignment is identical assuming 4 degrees of misalignment between center axes. The bottom faces are rigidly supported. The friction coefficient assumed to be 11/100ths for lubricated surfaces. Contact surfaces are assumed to exhibit no penetration of one another, and male run-out surfaces are assumed to be at the minor diameter of the male thread. Material selection is important. 410 martensitic stainless steel, the standard. Optimal for gas compressor applications, good corrosion resistance, moderate yield strength, can be heat treated for better mechanical properties, magnetic, suitable for mild chemical environments. 316 austenitic stainless steel. Optimal for marine applications, great corrosion resistance, poor yield strength, cannot be heat treated to gain better mechanical properties, non-magnetic, mostly chemical resistant. 4140 annealed steel, standard. Economical for moderate loading with no corrosion concerns. Poor corrosion resistance, moderate yield strength, not chemically resistant, not suitable in marine environments. 4140 heat treat alloy steel. Optimum for extreme loading. Poor corrosion resistance, good yield strength, not chemically resistant, not suitable in marine environments. And other materials are available upon request, so consult us regarding your unique application. In conclusion, you can save man-hours in the field. Disc level allows for machine foot leveling with small angle adjustment up to 5 degrees for adjustments in the field, not just in a manufacturing environment where components and surfaces are nearly perfect. You can line up ticks for quick adjustment, eyeball height increment adjustment, visible with 1/1000th of an inch increment ticks. It eliminates trial and error adjustment. Help prevent sticking. Acute face angles encourage fluid and degree to channel away from the threads instead of tunneling them into the threads, as is apparent in other designs. Distribute weight equally. Weight is distributed efficiently against concave-convex contact faces as demonstrated in FEA modeling, and distributes weight equally against the threads whether misaligned or not. Select the right metallurgy for your application, whether for marine applications, gas compressors, or other heavy equipment leveling. Disc Level, a product of Turntech Manufacturing. www.disclevel.com 307-266-5552.